For centuries, the speed of light stood as an unwavering benchmark in our understanding of the universe. It was a constant, a universal truth that defined the very fabric of reality, a speed limit that no object with mass could surpass. This notion, rooted in the theories of classical physics and later solidified by Einstein's theory of relativity, shaped our comprehension of space and time. Yet, as science advanced, so too did our curiosity about the cosmos, leading us to question the boundaries of this once immutable law. The journey into the depths of light's speed began with the mind-bending concept of quantum entanglement. Here, particles became mysteriously linked, their states intertwined regardless of the distance separating them. This phenomenon suggested that information could be shared instantaneously, defying the constraints imposed by light speed. If two entangled particles could communicate faster than light, what other secrets lay hidden in the quantum realm? The implications were staggering, hinting at a universe far more interconnected than previously imagined, where the traditional rules of distance and time began to blur. As researchers delved deeper into the quantum world, the idea of tachyons emerged, hypothetical particles that could travel faster than light. Although never observed, their theoretical existence ignited the imagination of physicists. Tachyons, if real, could revolutionize our understanding of causality and the flow of time. They opened the door to a realm where time could be traversed in reverse, where past and future might intertwine in ways we could scarcely comprehend. The mind raced at the thought. Could we one day send information back in time? The very fabric of reality seemed to stretch and bend under the weight of such possibilities. Yet, the cosmos held even more tantalizing prospects. Black holes, those enigmatic giants of gravity, had long captured the fascination of astronomers and physicists alike. Their gravitational pull was so strong that not even light could escape, creating a one-way ticket to an unknown realm. But what if black holes were not merely cosmic vacuum cleaners, but gateways to other parts of the universe? The concept of wormholes, hypothetical tunnels through space-time, emerged as a potential solution. Imagine stepping into one end of a wormhole and emerging instantaneously at a distant point in the universe, bypassing the vast emptiness in between. Such shortcuts could redefine our understanding of distance and travel, transforming the universe into a more navigable expanse. Furthermore, cosmic inflation introduced another layer to our comprehension of space-time. This theory posited that the universe underwent a rapid expansion just after the Big Bang, stretching the fabric of space-time itself. This expansion not only shaped the universe we see today, but also suggested that regions beyond our observable universe might exist, hidden from our view. If space-time could stretch and warp, what other phenomena might exist beyond our current understanding? The potential for discovering new realms, new dimensions, and new laws of physics tantalized the scientific community. As we stand on the precipice of this new era of exploration, the implications of these theories ripple through our understanding of reality. The speed of light, once a steadfast sentinel, now faces a challenge from the very fabric of the universe. What if the limits we once accepted were merely stepping stones to deeper truths? The universe, with its mysteries and wonders, beckons us to look beyond the horizon of our knowledge. In this age of discovery, we are invited to dream boldly, to envision a future where the boundaries of space and time are not fixed but fluid, where the cosmos is a tapestry woven with threads of possibility. The evolving understanding of the speed of light and its implications invites us to question, to explore, and ultimately, to expand our comprehension of the universe and our place within it. As we delve into the mysteries of the cosmos, the journey itself becomes as significant as the destination, propelling us toward a future rich with promise and discovery.